All right, so let's talk about Ferris wheels. Now, last week in our last video, we talked about um, Ferris wheels, and we talked about finding the height from the center of the wheel. Right, either from the center of the wheel, we have to either add or subtract from the center so that we can like draw a triangle and then add and subtract. Right, so we did something along the lines of like you know, if B is the height that you're looking at, we know the height from the middle to the ground. If this is, let's say, 30 feet or something like that, and we need to use sine theta to find out what this missing length is going to be. Now, today we're not going to do that. Today we're going to just see that actually depending on how much you've rotated, which is called the angle of rotation, whether that's your angle of rotation or you've rotated all the way to H or something, that's all we need. That's all we need. So ignore the words and stuff like that. I'm not going to go over the warm-up. I think most people did not have any issues with that, so I'm not going to go over that. Okay, so let's see what is given to us here on page 16. We have a radius of 30 feet as well as it is 45 feet above the ground. So let me just label that a little bit. So this is 45 feet, right? Because that's the same thing as this. That's the same length. We also have the radius. Now, the radius for now I'm going to draw as B, or rather centered to B, because we're going to be looking at B later. So just so I'm kind of saving one step here, this is going to be 30 feet. And we want to verify the expression that this can be used to determine the height from B. So from what we learned last week, right, we said that, okay, well, if I want to find this height from B all the way down to the ground, well, I can break this into two parts. I know that this part from here to here is 45. This is the same. They're the same length. So that's going to be 45. Now I need to figure out what y is. Well, if I know what theta is going to be, then I can use sine of that angle, which I can figure out is opposite y over 30. And I know that this is broken down into 10 seats. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 360 over 10, because there's 360 degrees in a circle, divided evenly by 10, that's 36 degrees. So this theta, this measurement is 36. And if I multiply 30 on both sides, I'm going to be able to get that y value. Now, because I do need to add, right, we're missing, all we've found so far is this piece, which is not the whole piece. That's just y. I need to add that 45 in there as well. That's going to give me my total height. Now, it doesn't ask us to calculate it, just to verify to see if that's true or not, and we see that this is in fact true. Now, if I want to, if I try to find, I'm sorry, in number 2 it says the expression 30 sine of 144 degrees plus 45 results in the same height. Well, let's first make sure that that's actually true, right? So if you use your calculator and you did 30 sine of 144 degrees, make sure your calculator's in degree mode, you'll find that these two values are, in fact, the same. So I'm going to just use my calculator. I know you can't see it, but I'm going to pull out my TI-83 Plus, and I'm going to go ahead and type in 30 sine of 144 degrees plus 45. Now, I'm making sure my mode is in degree mode, and I have 62.6. So I found that this is 62.6 degrees. And I'm just going to just calculate the other one as well, just so I kind of have these like on whatever, just showing that these two are the same amount. Obviously, that's an estimation because it keeps going, but these two are the same, and that should make sense because, well, if we try and figure out what is this rotation 144, because if we take a look, these two, the only difference is the angle, right? So, well, what is 144? So let's see, 144. If we divide that by 36. 144 divided by 36, that's going to give us 4. What does that mean? Well, that means I've traveled, let me use a different color here. I've traveled 1, 2, 3, 4, right? Which is the same height as E, right? So that makes sense. So because seats B and E are at the same height. Right? So again, this is why, and in fact, this is part of what I mean when I say it doesn't really matter if we necessarily know like how much higher, how much lower we are than the center of the line. What we can do is, as long as you know your angle of rotation, whatever that angle of rotation is going to be, your sine function is actually going to take care of that addition or subtraction for you. So, but we'll get there a little more later as well. For now, let's take a look at this expression and try to figure out like a general formula, which we kind of done, but not really. We know the 30 here stands for the radius. The 36 represents the angle of rotation. And the 45 represent, now the 45 later on, we're going to see this as more like a translation, like how much do we move up? Like it's a vertical translation. For now, I'm just going to say D for distance from the ground, right? Or distance center to ground. So we can actually create a general equation or formula for the height at any point. We can say H is equal to R sine theta plus D. Okay, later today we're going to kind of break this piece down a little bit, but it still means the angle that we have. So let's take a look just as quick practices. If we change the dimension of the Ferris wheel to a radius of 40 feet and just the Ferris wheel at 55 above the ground, the equation to calculate height at point B would be, well, these are all point B, so I'm going to just put in 36 for all of them for now because it's the same Ferris wheel as earlier. But remember, it is r sine theta. Now, in this case, theta is just 36, plus the distance from center to ground. So this is 40 sine of 36 degrees plus 55. So I'm just using what the radius is and what is the center above the ground to substitute in for my variables. Diameter is 150. Be careful here. That means the radius is 75. So 75 is my radius. Sine of my angle, 36 degrees, plus 90 feet above the ground, plus 90. Same thing for the last one. 245 is my radius. Sine of the angle, in this case 36, plus 275. So really, once I know this equation, all I got to do is substitute those numbers in. Now here's a different concept. Now we know, now we're kind of sticky, we're fixing the radius as 40 feet. Center to the ground is 50. So you can see these are all 40, 50, 40, 50. Okay. Now the difference here is we have a new idea or a new information that's given to us. The Ferris wheel makes a complete rotation every 20 seconds. Okay. So the first thing you should think about is, well, what does that mean as a speed, as a rate, right? Because you can think about it, rotation as kind of like the distance that you're traveling in a circle. In this case, our quote-unquote distance is the angle, right? Degrees. Well, how many degrees are in a full circle? A full circle is 360 degrees, and it takes 20 seconds to travel that, right? In the same way, we have some kind of distance over time would be velocity, right? This is also distance, quote unquote, is our degree, right? So this is actually really angular velocity, but that's okay. We're not going to go that deep into it. We're just saying it is some speed. This is going to be 18 degrees per second. Now, that means, well, now I don't really have it broken down into like each seat the way that this was broken down into each seat, but rather now this is broken down into per second. And what's nice about this is I can multiply by t or time, and in this way I can figure out any point on the circle as long as I know how long I've been traveling. So for example, let's say I've been on this Ferris wheel, right? I'm on this Ferris wheel and I know I'm going, let's just use this number, 18 degrees per second. And I know I've been traveling for, if after 1 second, I know that I've traveled 18 degrees, right? This means 18 degrees we've gone to 18 degrees. If it's been 2 seconds, I know I've gone 36 degrees. right? If it's been 3 seconds, it's going to be whatever this is going to be 40, 50, 54 degrees, right? So, and if I wanted to calculate in betweens, I can do that too. If I've traveled 3.5 seconds or 10 minutes, no matter what, as long as I know the time, I can figure out my height. I know the degree that I've gone in because that time multiplied by rate, I'm going to get that degree. So this is a hidden view, not view, I guess, but a hidden, I can't draw the bracket. There we go. This is my theta, but now as a distance and a rate, or a rate times the time. Okay, so I can do that for every single one of these. Again, complete rotation means 360. How long does it take me to do that? It took me 30 seconds. So this is 12 degrees per second. Right? So again, this is, again, as long as I know how much time has passed, I know how much of a rotation I've gone through. Okay, same thing here, right? These are just example questions, one example. 360 over 45. That's going to give me 8 degrees per second. So this is 8t. So obviously, as we're doing this like back to back to back, it's the same thing and over again. But really the important thing is that we're able, whoops, not 45 this time, we're doing 60. But the important thing here is being able to use this concept along with my previous concept, but putting them together. Okay, and the last one, I'm not going to do this, the same thing again. I'm just going to do 360 divided by 15 and then 36. So I'm not going to do this. Okay, now here's another, I don't think it's a hard concept per se. It's pretty straightforward, I think. But before we get that, we'll just do this problem. The 13 is important. So let's take a look. Radius of 45, center of the wheel is 60 feet above the ground, makes a complete rotation every 40 seconds. Let's do this calculation real quick. 360 over 40, that's going to be 9 degrees per second. I can write in the units there because they tell us, write an equation that can be used to determine the height based on time. So this is a little bit different. My general equation I said earlier was H is equal to R sine theta plus D, right? And the thing that is my variable is my theta. I don't know what angle that I need to go. In this case, it's a little bit more complicated, but I have H of t because now I should really have H of theta here. But now it's H of t because now it depends on t. R sine, and I guess I can write this, I don't really want to write it as a rate. I guess I'll write rate times time times t plus d. I don't want to write 2r's. That's kind of confusing. So it's a rate times a t, whatever the rate is. Now, so that means in this case, H of t then is equal to R, 45, sine of 9, because I figured that out. Ooh, that's not 9. 9t plus 60. Now, this is a sort of a new way of thinking about it. Now, there's a couple ways to do this. So assuming that the writer starts at point A, right? So that's what we've been starting this whole time. After how many seconds will it take for the writer to be at the highest point? The highest point is over here. Well, here's a couple ways to think about it, right? Because one, you can think about it as, well, the highest point is, of course, 90 degrees from my original starting point, right? So that means 9t. Well, how long does it take for me to travel 90 degrees? If I divide both sides by 9, t is equal to 10 seconds, right? So that's one way to do it. That's one way to think about it. Another way to think about this is say, well, how much of the circle did I travel, right? Well, if it's, again, 90 degrees, I know that it's 1/4 of the circle. If it's 1/4 of the circle, that means it's going to take 1/4 of the time as well. So it's going to be 1/4 multiplied by how long does it take to travel the whole circle. That's also 10 seconds, right? So both methods work. And this logic extends out to the next two questions as well. How many seconds will it take to travel to F? F is over here, right? That's halfway. So again, I can say, well, that's half of the circle. So half the time is 20 seconds, right? You can also say, well, 9t has to equal to 180 because that's half of the circle. Divide by 9, t is again equal to 20, right? So both methods work. They're both going to work. Lastly, how long will it take to be at the lowest point? The lowest point, of course, is going to be, now be careful here because a lot of people mess this up, okay? Because in terms of Ferris wheel, or at least our Ferris wheels, they're going to only go counterclockwise. So it has to move in this direction. Meaning this is traveled 3/4 of the circle. 3/4 of 40 is, of course, 30 seconds. Same thing here. I can say 9t has to equal to 270 degrees. Therefore, t is also 30 seconds. 17, 18, all I'm doing is taking the equation that I had from 13, and because they tell me how much time has passed, all I got to do is substitute that number in. So h of t is equal to 45 sine 9t plus 60, I believe. Yeah. Right? And I need to know how long after 15 seconds, so h of 15, that's equal to 45 sine of 9 times 15 plus 16. I would just put all this into the calculator all at once without trying to figure out what 9 times 15 is. Now, for some of you, that it might make more sense to say, well, I want to figure out what the degree is first, so 9 times 15, whatever that is, then I plug it in. I mean, that's fine. It's going to be slightly more work. But that's all right, whatever way makes sense to you. So 45 sine of 9 times 15, close parentheses, plus 60, that's going to give me 91.8 feet, about, approximately. Okay, and this is a good way to kind of think about this, also to kind of just self-check yourself, right? After 15 seconds, well, where am I? 15 seconds, I know if it takes 20 seconds to go halfway, 15, and then it also takes 10 seconds to get to the top here. This is 10 seconds, 20 seconds. It's somewhere in this region, right? If it's somewhere in that region, it needs to be greater than 60, right? Because it's 60 feet above the ground, but it has to be less than 105. That actually looks like 105. Okay, that has to be less than 105. Well, 91 is right in between there, right? So again, that's not perfect. It's not going to guarantee your answer, but at least this answer makes sense. Similarly, for number 18, h of 25 is going to equal to 45 sine of 9 times 25 plus 60. So same deal. I'm just going to change my 15 to 25 instead. And this time, I get 28.2 feet. Once again, where is 25 seconds? I know that down here is 30 seconds. 20 seconds is here. So this time I'm somewhere in this region. Again, 60 is up here. 60 minus 45, this is 15 feet. 28 is between 60 and 15. So this again, doesn't guarantee that it's correct, but it makes sense. So let's put everything together in terms of what you might see on the checkpoint or on the formative, right? So Stacy starts position A, as always, and the distance from center to A is 50, so the radius is 50, okay? Be careful here. This is the radius. The distance from center to ground is 80 feet. The shortest distance, of course, is going to be right here, and that's going to be 80 feet minus 50 feet, so that's 30 feet. The furthest distance is going to be at the top, so I have to add them. 80 plus 50, that's equal to 130 feet. How far is she from the ground in the beginning? Of course, it's the same as from the center, so 80 feet. There's no calculation required here. Again, they tell me the rotation here, so there are no seats, or at least there's no, there might, there's obviously a seat on Ferris wheel, but there's no, positions on the circle. So all I need to do is to say, well, h, my height, is equal to r, which is 50, sine of the angle of rotation, so 63, plus the height from ground is 80. I'm going to substitute that. I'm going to put that all into my calculator. 50 sine of 63 plus 80. That's going to give me 124.6 feet. Again, I can do a quick check for myself. 63 feet is, 63 degrees is not the highest point. And my highest one's 130, so this is lower than that. But it's for sure going to be higher than A, right? B is higher than A. So that's greater than 80, which is great. Okay, so this is my answer. Now, if it takes 40 seconds to make a full rotation, again, full rotation means 360 degrees. So 360 over 40, that's going to be 9 degrees per second. How many degrees does the Ferris wheel rotate after 1 second? Oh, well, there we go. It's 9 degrees per second. So 9 degrees every second. But this means I do need to switch up my equation a little bit for the next question, because I don't know the degree. I don't know where the degree is. I only know the time. So again, you can either do 9 times 18 and figure out your theta first and then use your original equation, or you can say h of t, or in this case h of 18, is equal to 50 sine of 9t plus 80. Right? All I'm doing is switching because I don't know this value anymore. I don't know what the theta is, the angle of rotation. It's 9t instead because it's 9 times. It's 9 degrees per second for 18 seconds. I can substitute this in. 50 sine of 9 multiplied by 18 plus 80. And that's equal to 50 sine of 9 times 18 plus 80, 95.5 feet. Okay, again, 18 seconds. Again, they tell me it's 40 seconds to make a full rotation, so halfway will be 20 seconds. 18 is just under that, right? So I'm somewhere over here. Well, if I'm over there, I have to be greater than 80, which I am, but then less than 130, which I am as well. So again, not perfect, but it gives me a general idea. I'll do one more example, and I'll be the end of this video. Okay, same thing. The distance from the center to A is 75. This is again my radius, and my D is 100 feet. What's the shortest distance? Distance from the ground to center. Subtract out a radius. That's going to be 100 minus 75 equals 25. The furthest is going to be the highest point, so I didn't add them. 100 plus 75 is equal to 175. How far am I from the ground right now at A? That's 100 feet. Okay, counterclockwise rotation 40 degrees. Again, all I need to do is to use R, 75, sine theta, which they give me is 40 degrees, plus 100. Which is 148.2 feet. Again, less than 175, more than 100. Looks good. If it takes 60 seconds to make a full rotation, that means 360 divided by 60. That's 6 degrees per second. This time they just want the equation. So h of t is equal to 75 sine of 6t plus 100. This will be 100 on the right. There we go. And that'll be the end of this video. Thank you so much for watching. I hope this helped.